Right, now we're going to look at a couple examples dealing with charged particles. Very similar process to what we did in examples 1, 2, and 3. Now we just use the other formula, magnetic force equals charge times velocity times magnetic field. So determine the magnitude and direction of the magnetic force on a proton moving horizontally to the north 9.2 times 10 to the 4 meters per second as it enters a magnetic field 1.5 Tesla upward. Start with a formula. Magnetic force equal to QVB. Put our numbers in. Since this is a proton, we know the charge on a proton is 1.60 times 10 to the negative 19 coulombs. We have the velocity of the proton, 9.2 times 10 to the 4 meters per second. And we have the magnetic field strength, 1.5 Tesla. Punch everything in. 1.6 to the negative 19, 9.2 to the exponent 4 times 1.5 should give you a magnetic force equal to 2.2 times 10 to the negative 14 newtons. Now we just got to figure out the direction. It's a proton, so we need to use our right hand. That's the key word. Proton is positively charged. Velocity is to the north, so that means your thumb points to the north. Magnetic field is upwards, so that means your thumb is to the north on the page and your fingers are pointing out of the page. It should look something like this on your right hand. Thumb is to the north of the page, fingers are coming out of the page, so your force should be to the east on a proton. Notice if this was a multiple choice question, I can guarantee you that they would have the number 2.2 times 10 to the negative 14 written in a couple choices, and one of the questions would also be east, the other one would be west for students who use their left hand, just to try to throw that extra little trick on you. These questions tend to be multiple choice on diploma exams. There isn't a lot of mathematics involved. Just make sure you got everything in the right units, and then just be very careful with your direction and which hand you're going to use.